Welcome to the 9th part of TIS-100. So it says, read from in.1 through in.4. Write the input number when the value goes from 0 to 1. And then 2 interrupts will never change in the same input cycle. Oh, so this is an assumption. And an interrupt is when something changes. So it says write the input number from 0 when it goes from 0 to 1. This didn't change, 0. This changed, so this is 4, which is in dot 4. This changed, so this is in dot 3. Nothing changed, so it's 0. Okay. This changed from 1 to 0, but it only matters when it's 0 to 1, so that's not an interrupt, so that's 0. This is that change, so this is 1 from 1. Yeah, okay, that makes sense. So what could I do in order to... Oh, wait a minute. I have 4 inputs. Ooh, okay. And I have 1 output in here. Okay. My first idea was like some weird way of having to convert these into normal numbers, but there is no division, but there is subtraction and addition, which means I can in fact do it, but that would be a horrible idea. So let me think. So yeah, that's a terrible idea. That'll increase so many cycles. I'm sure the easiest way is to have have 2 values. So I do the comparison here, because I'll do the trick I did in the last episode, where I send, so I do move up ACK, then I do move ACK down, move ACK down. And what I'll do is I'll compare the ACK. I'll do the same thing here. I guess I'll just copy it. Okay. Then here I'll do I can come back and I can probably steal some information like this thing. So basically I'm swapping ACK and back. I'm storing my previous value of back into ACK. Then I'm getting the value, swapping back as in BACK, and then I'm subtracting by up. But I don't want to be doing this. I want to do jump less than 0 or jump equal to 0. Sub 1. I think sub 1. No, sub 1 won't be. Is there add nil, add 0? Something like test in x86 in here? I don't think there is. Gr 0, jump, negate, sub, add, save. No. I should be familiar with the manual. If it's equal to 0. Ooh, yeah, the issue here is that I have to compare. Yeah, no, that's fine. Is it fine? Okay, so this is just like, it's gonna be clearly wrong, but I just want to debug. So I'm taking an input, I'm moving it down, and I did a swap. Oh, having this at 0 is awful. And it does that, whatever. I'll just move left, right, or down. Move up, right, move. Wow, wait a minute. I won't be able to do that for each one, will I? That's interesting. So there has to be a better way than doing this. Maybe. Anyways, move left, down. So it's gonna give me a bunch of incorrect answers. But what I want is... I just want to... Oh, it's only going to be zeros and ones, so it's going to be really hard to judge. So I'm going to wait for that one input, because that's what's necessary. Okay. That's still 0. And that's 0. And that's 0. And that's 1. Saves 0, 0. Now 1. Now it swaps. Wait, that means the previous value was 1, right? No, it was too late. Yeah, okay. Okay. I take in an input. I swap, I save the input. I move up the accumulator. I swap. Okay, I need a way of understanding this. So I swap. This is 1, let's say this is 1, this is 0. I'll swap it. This is 0, this is 1. I'll save it. This is 0, this is 0. Then I receive a 1. Then I think I subtract. So what was I doing here again? I was subtracting. I nearly erased it. Like so, I subtract it. Okay, we don't care about the right answers, we just want a 1. There you go. That's a 1. And that's a -1. Yeah, so basically if it's less than 0, then I go to less than 0, and then less than 0 is move 1 right. And then any, you'll have to use any, move 1 right. Else move nothing. Else we don't move anything. Right? Else we'll just jump to the start of the loop. Nice. Whatever. But when there's a one change, it should work. There you go. Oh, but we have to... we don't. Okay, let me... This is the first time I'm using this, but... Oh, that's fantastic. I like that. No, it's just giving ones forever. Oh, because it's moving it down. How about I stall this, I stall this. We don't need to stall those. Boom. So let's say I move 0 down. 0, 0, 0. Wait, that's supposed to be a 1. Right. Yeah. Okay. So what number is it? 0, 0. That's a 1. So it should keep giving ones? Oh no, it shouldn't. Then when that changes, yeah. That changes. Yeah, it looks good. That's kind of what we want. There's a stall. Probably because we're waiting for this. Okay, so this is kind of it. But we'll need to do this here as well. Whoops. Up, down, and then move left down. Let's go. Then. Else, if nothing changes, it'll be a 0. It's not 2, it's 2. Oh yeah, that thing. It's hard to follow that. Three down. Oh, this looks actually more awful than I thought it would. For some reason, left. Any down. 4, 3. Wait. 4, 3. 3, 2. Ooh. Probably a bad. The first thing that changes is clearly 1. 4. 4 changes first. Yeah. And if none of those change, and if any, I guess any ACK, and then you say JLE. Oof. No, we can't do that. We'll say if yeah, if input is 0, then we want to pass down 0. We want to pass down 0, and we just want to add. So when there's a 4, I'm gonna send down 4, but I'm also gonna add. I'm gonna add all of these together because only two interrupts will never change. That means when there's one interrupt, I can do 4 plus blah blah blah. And that makes it so when I pass 0, 0, 0, I'll do 0 plus 0 plus 0 plus 0. Yeah, okay, so that means I need to JLZ move. Z move. So that means I accept it on the left. Which also means I accept left down. And then I did the same thing here. So it means I need to accept 4 inputs. Move up, right, move up, right. Move, so you want to do add up. I guess I'll do add left. Left, accumulator, add left, add left, add up, add right. Oh, we don't have to worry about the left one here. Just send 0 down. Okay. Okay, that's awful. 0 down. Add left, and then you say move accumulator down, and then we say accumulator 0 accumulator. Keep mixing up x86 syntax where it's instruction. I'm even not remembering. It's instruction, destination. Sorry, instruction. Yeah, destination up value. With this syntax, it's also in RISC. It does it the other way around. I'm pretty sure. Anyway, we want to reset it. Yes. Four, please be 4. Oh, look at that. That was pretty good, and it was all because of that edge case condition. But again, oh, that's pretty good. 431 cycles. It's not too bad. Clearly, I'm doing a lot of copy pasting using that technique, which is probably inefficient. And I'm really scared that it's gonna cause a huge problem later on because maybe the developer didn't think that I would be using this like inefficient technique in the program, and then he gives me a problem where I can't use this and I'm gonna be hard stuck. But we'll get there when we get there. Can I optimize this? Because what's happening is boop, boop, boop. It's just it's fantastic how fast I did it, but it's not the prettiest, I must say. Because it'll need to do lots of addition. Yeah, and it's all of this addition just because we have to return 0. In the case that all of those haven't changed. Yeah, I'll keep it like that. I'll say that's good enough. Thanks for watching for this episode.